So, shall we get started then? Appears to be 10 past 10. Yeah, stop talking. So, we're just going to start with a quick summary of where we are in upstreaming the ACPI patches, and then I'm then going to hand over to Hanjun, who's going to give you a quick 30-second rundown of the patch series, just for people that aren't familiar with it and haven't been tracking it on LKML. Then we're going to get on to the more interesting stuff that's been discussed over the last week. So over the last few kernel cycles, we've had quite a few core patches accepted. So cleanups, changes, 5.1 changes that aren't specific to ARM. Currently the ARM server patch set is at v4, and so we're processing reviews. Currently it seems to be going in the right direction. People seem to be happier with the patch set in a technical sense. And so we'll just continue with the standard kernel upstreaming until we've collected all the acts we require and everybody's happy with the technical sense of things. So now I'm going to hand over to Hanjun, who's just going to give you a quick rundown of the patch series, basically one-liner for each patch, just for the justification.
Okay, so this patch series is included 3 parts. The first part is some cleanup to the ACPI core, and the following part just for the ARM64 ARC-dependent code. The last one will enable the ACPI on ARM64. So the first one is that the CPU logic map, will be used as the mapping of the CPU hardware of the MPI ID we needed by the ACPI. So we move that initialization before the unfrightened device tree. The following one is that, and the second and the third one is that we just some update for the ACPI core, for the passing the MATD tables. And the get RSDP and the ACPI prototype tables, we will get the the root pointer of all the ACPI tables, and prepare for the following table passings, such as MADT, FADT, and the sleep arm. Some people point out that the sleep things on ARM is not defined well in the ACPI spec. It's x86 specific, so we sleep ARM specific file to compile out such kind of things on x86. And the earlier pattern for the ACPI, we will introduce the off to turn the ACPI off at the boot time, and we will also introduce force to force ACPI on. So, and then if we choose to boot from the ACPI, then we will disable the device tree at runtime, not totally disable them. The PCI part, for now the kernel, me on the x86, the ACPI depends on PCI. But actually, for the ACPI spec is no such statement. So we just make the PCI just optional for ACPI. And the last one is that these new features was introduced in the ACPI 5.1. It's about the PSAI. So we introduced the PSAI flag to indicate the PSAI is valuable or not. It's using the HVC or SMC for the conduct. So we just pass the MADT to get such information. And the first one in this page is very simple. we get the MADT table and print some gig information. This is we make the bootlock is pretty, and sometimes we will use that information for the debug. I mean, we can debug some things in the firmware, to say that if the table is okay. And the second one, we will get the information from the MAD table for the SMP initialization, such as the MP IDR value, and to bring up the secondary CPUs. We can see that in the formal patch, we just get the PSCI information from the FADT. So for now, we just support only PSCI to bring up the secondary CPUs. And the ACPI processor is just needed by the ACPI core. We will get the CPU hardware ID, the MPIDR, from the MAD table to accommodate the processor driver in the ACPI core. And then after we bring up the secondary CPUs and the following patches, we will get the something really the IQ for the interrupt. We get the devices GSI is the global system interrupt, and then connect to the IQ core system, and then the devices in the DSC will be functional.
What's GSI?
GSI, global system interrupt. So it's the hardware IQ. And then we initialize the gig V2 from the MAD table, and we will initialize the arc timer from the GTDT table. This table was updated in the 5.1, to support some memory map timer, the SBSB compatible watchdog timer, but it's not included in this patch set. We will prepare it later when this patch goes in. And the reduced hardware, x86 Antenna is not hardware reduced, but ARM is. So we.
They are using other x86 sometimes.
So that's for the embedded system. But for ARM, we just use the hardware reduced mode. So we will enable the hardware reduced mode on ARM64. We must use that mode. And the following thing is simple. We enable that on ACPI on 64, and we prepare a very good document from Graeme to say how to use the ACPI on ARM. And what's the constraints for now? That's all.
So that document is still under discussion, and for reasons as we'll pass on to the next slides, which is the non-technical, what we still have to do. So talking with people this week, we still have process issues to work over. So one of them is, in the ARM server, we don't have the de facto standard of it'll boot Windows, which kind of gives you a baseline test. So we need some sort of test suite to say, well, this ACPI tables are compliant to something, and so therefore we've got a good judge that the Linux kernel will work with them. Kind of tied into this is the handling OSI. Obviously, if you're familiar with x86, every Windows release, they add a new OSI string so that you can expose new functionality. Like a good example is the backlight, which has changed for Windows 8. So Windows 8 can use the new functionality. Windows 7 still uses the old functionality, both for in the firmware. We just haven't even started to discuss how to handle that. So obviously, we've got at least 2 server platforms. You've got Red Hat Enterprise Linux Canonical, possibly different kernel versions in their server enterprises releases. And so it's possible that they're in the same state, that they'll have different interfaces. So we need to have a discussion about how to handle this. And we still don't have a clear reference platform of what we mean by ARM server. Grant, it's the big square thing.
Yeah,
Okay. There is a mic.
Holy cow. I have a comment on some of the bullets here. In terms of the test suite, I think what we are looking at in the UEFI forum is an ACPI SCT, if you will, self-certifying test. What we are looking at right now is the option or the possibility of using the FWTS out of Canonical. And they told me that it is already ported for ARM. So that's something that you guys need to look into. Yeah. The second thing about the OSI, I think my suggestion is not to use it in ARM, because in x86 we are already deprecating it. The replacement is _OSC, I think. So instead of saying, oh, I'm Windows, which I think Linux is saying that on x86 as well, it doesn't make any sense to use that OSI anymore. And we have the OSC, which gives you the capability of having an interface between the OS and the firmware to communicate what the capabilities are in between the OS and the firmware. So look into OSC and ignore OSI.
Okay, thanks for that. Yeah, onto the last point on this slide. We still don't have a very good view of what we mean by ARM server, and everybody we talk to seems to have a different opinion about what we're actually talking about. And so it's very hard to get a targeted functional subset to say, well, to start with, we just want to target this, and we want to make this work well. And then after that, we can obviously expand, but we have to start somewhere. We can't do everything as an initial start.
One of the things that came up is very much for a reference platform is testing of is it going to be readily available for once you get these patches merged into mainline? Are we readily going to be able to test those on hardware without NDA or problems talking about the results of those testing?
And then the final one, a lot of people have seen discussions about _DSD. We still need basically to decide what processes for handling these bindings. So we've only just started that process, basically.
I think with that discussion, we're going to conversation is going to be started on the mailing list, and we'll go from there. Can we back up a slide for a second? Just to go back to the testing, the other thing that came up is some of you will have seen Matthew Garrett's blog post, and the issue that he brings up very rightly is that the support for the platforms is very much tested on the platforms that are run on it, or sorry, the versions of the operating system that are run on it. So not only do we need the test suite, but we also need the test suite to be testing many different versions of the Linux kernel, so that we've got a wide coverage. Because as behavior, just as we do the software development, as the behavior of ACPI in the Linux kernel implementation slightly changes between kernel releases, that we're catching problems that are going to happen with individual platforms. So we want to have a very good suite that for the vendors, as a baseline, the vendor should be able to pass this test suite before the product comes out onto the market. And then we also need to talk about how do we make sure that the Linux kernel, as we continue to develop it, will continue to be tested and working on platforms that have already been released and deployed out into the market. So that's the conversation that's been going on.
Basically, this way we can open up to questions, a discussion.
I mean, making sure that new OSs run on old hardware is something that hardware vendors worry about a lot today. I mean, new kernel, the latest upstream kernel, we make sure it runs. Sometimes it doesn't on our older platforms, but we have to fix it, and we, work with, the distro releases as they come out. I mean, it's really important to us that we certify the, Rails 11, SLES 12, the latest Ubuntu. I mean, that's just part of being in the server business. We have to make sure that all this works. And so we try to track the upstream kernels and make sure that if there are regressions that they get fixed, and so that the fixes roll in. The green box is much better.
Can you say, if you find regressions, how often do you fix those by reverting patches in the kernel or fixing stuff in the kernel, or how often do you fix them by updating the firmware?
Well, sometimes we fix them by updating firmware, and this is firmware that runs Windows just fine. So I'm not, we run a lot of Windows on our systems, but we still find firmware bugs with Linux, and we fix them in the firmware. And then other times, we typically don't revert patches. We fix the problem.
Yes, but if the problem is that the kernel was obviously broken by a patch, that should be reverted.
Well, so we don't ship our own distro. So if a distro backports something that we think is broken, we would work with the distro to maybe not backport that yet until there's a fix to the upstream patch that broke it. And that happens sometimes. I mean, it's happened pretty recently with some IOMMU support that Intel posted. It broke our platform. They fixed it, and luckily they fixed it before any distro backported it, so the bug never appeared in a commercial distro. And that's generally how we work.
Yeah, but which one is more common? Do you get to fix more stuff in the kernel or more stuff in the firmware? Or is it how hard?
I mean, the stuff that we tend to have to fix in our firmware is usually, value add that we didn't quite get right. And so, yeah, we fix our firmware. But I don't know. I think the kernel is generally pretty stable, and we're amazed at how people are still running new kernels on old hardware that, we technically don't support on the newer distros, but until we do something like, remove an old driver, like, if you track x86, you might know about the KISS driver, and that's not in Rails 7. So we're about to find out Rail on platforms that only work with the KISS driver. So it's amazing how things keep working, even though we're no longer testing them because the hardware is so old, it's well out of warranty, and you can't even get parts for it. Somebody else gets the green box.
Maybe I talk something, and
No, I'll just take it back to the
so for us, and we view the decouple of hardware, software is very important. I'm from hardware side. Basically, the CPUs, just advance so fast. So, and customers usually don't want to update software, and we want to create opportunities that we can sell faster CPUs with lower price into the market. So, this type of requirement, ACPI, is very critical for us. Without that, we lost a good chance to use new CPUs, right? And the customer is not happy also.
I'd like to talk a little bit more about what we were talking about with support, just for when it comes to the question of, the big question is when is this actually going to get merged into mainline? And we do not have an answer to that yet, because there is still concern about will it end up creating a support main. One of the things that has happened, for us as kernel maintainers is we've got plenty of battle scars of horrible things that have happened trying to support Linux on machines that were built and never actually really designed to run Windows, or sorry, to run Linux. They were machine, laptops are the big example. There's all kinds of work the distros will talk about of how difficult it has been to support laptops in a market that is primarily, these things are built primarily designed to run Windows. And then all our support comes out because there's varying levels of testing that the vendors will do with Linux. Linda, can I put you on the spot? Can you talk about like how do you view different market parts of the segment when it comes to Linux?
So, we do sell a lot of servers running Windows, but I can tell you that what our manufacturing and diagnostic tools are in our factory, they're all Linux. We have servers, and I expect the ARM, the Moonshot servers are primarily targeting a Linux market, and so that's what's going to matter for us. But even supporting Windows on x86, there are things that Linux cares about from an ACPI. Oh dear, oh it's back. We went for years with broken slit tables that Windows doesn't use and Linux does, and we discovered that, and we had to fix our firmware to work with Linux for things that Windows just doesn't care about. But we have a pretty big market for hyperscale and servers that I didn't even talk about on Wednesday, and those are 100% Linux, so very very important part.
Any other questions? All right. Well, we'll close this up as. No, we're done. Okay. Well, we will close up this session. We will keep you posted as to try to get things sorted out, and when there's a better idea of when these patches are actually going to be merged. I'm going to go out on a limb here. You guys might disagree with me. The merging of the ACPI patches is no longer really an issue about the technical quality of the patches. They are in great shape, and these guys have done a fantastic job. It's now a question of when, and that's got to do with are us as Linux maintainers confident that we're going to be able to support these? It's not going to be a support nightmare. And when is there going to be hardware available to test it? And then a few of these remaining questions of, are we doing the right thing with OSC, OSI? And those are conversations that can happen fairly quickly. But watch the mailing list. We'll keep you posted as decisions get made. Okay, thank you very much.